Hello, and thank you for joining me today. Okay, you're here with data science teacher Brandon, and we're going to learn how to build the Perceptron, a very basic model, the functional API. And I think the main goal of this is just to practice how easy it really is to use the functional API. We have so much flexibility with it, and we can build the simplest or really quite complex models with it. And it's not specifically a whole bunch more difficult than using the sequential API. It's more advanced, they say, but it's really not that much. You have to think, there's a little bit more thinking, I guess, that goes on, planning out how you're building your network, but it's not truthfully so much harder. The syntax too. All right. Okay. So what I'm doing for this one, I'm just importing make classifications. I'm making a classification data set, making up a data set of 5 classes. Okay. And so, this my sample is 2,000 rows, 15 of the 20 are informative, and I have a good there's some separation, but it's not a huge amount of separation. So you could make it easier if you turn the number of clusters down per class and the separation between the classes up higher if you want to make your challenge a little bit easier. Okay. And here just plotting each one of the classes, and you can see really overlapping in here. So it's hard for our models to find the difference in these classes. Okay. So train test split using sklearn and splitting it between xtrain, xtest, ytrain, ytest. I'm just using R and S to have less writing because I'm a little bit lazy. And honestly, R and S is pretty easy to understand. Okay. There's something you write so much, it's just easier to keep it small. Okay. Importing TensorFlow or input or dense layer in. So we're going to put the input shape is going to be, and there's the comma here. Okay. I'm going to say the number of columns in my X data, and my input layer is then using input layer from TensorFlow, from Keras, and then putting in the input shape. Okay. And nothing super fancy here. If you're using 5 neurons, I think the more classic perceptron, we only need 1 neuron. 1 neuron gets you a linear regression, right? Every neuron is one linear regression, a very simple linear regression. And so if we want something a little bit more fancy, using 5 here, nothing super fancy. Because I'm using 5, if I use more than one, I'm going to use the softmax activation, because this is also my output layer. And that's the thing, is we're going from one layer right into our output layer. Okay, so we're taking data in, and it's passing through one layer of our neural network, the perceptron, and then into our outputs. Okay, and so here are the number of drones. So basically, what this is happening is this is essentially like 5 linear regressions, and our softmax activation is going to choose whichever one is the the highest value for our to decide which one's the class for our classification of 5 classes. So you just note to note this number will need to match up to the number of classes that you have in the data set. Okay, or so you're making your in the data. Okay, then the way that we define the big fancy thing, nothing is really different. Notice here that we take our input layer and we're multiplying. It looks like we're multiplying it by our dense layer. So it's just these two brackets. It's not multiplying. This is a quirk of Python, and it basically means this function is happening on the inside of the other one. Okay, so this one executes and this one executes, and that's all it is. So it's not really multiplication. It's just Python, the way that you can write Python. It makes it really easy to write this. This is kind of a nice thing about Python that you can use super quick and easy. Then, so we define our layers, and if you define more layers, again, be the same thing. What we're going to do is then we're going to define our model by defining our input layer and our output layer. So it says, notice here it's inputs and outputs, because you can have more than one input and more than one output. Okay. So this is really simple. Okay. So compile, nothing really different here. Compile optimizer losses sparse categorical concept because I'm giving one column of data, so it has to be the sparse categorical concept. When it says one column of my y is not 100 encoded yet, it's just one column. And then just ask for the accuracy as well. 50 epochs, batch at 32, and then go through this. And train, you see here, get a decent score, nothing too fancy. When we plot the model, pandas is a really good tool for this. Just default plotting option works really well. So I'm going to put history.hist or h.history. So it's going to be fitting the model. I'm going to put that right into dog plots. Big size, model training history, and evaluate. After my training history, you can see it bottoms out pretty quickly. You probably didn't need to train it, but maybe 10 would have been very, very close to the same. Okay, it's just such a simple data set. And here evaluate, train, and evaluate the test. Okay, I'm going to do a little quick comparison with sklearn using the logistic regression and the random forest classifier. So you see, super quick, just import them, initialize and bit, and then just get the score from them. And bit. You'll ask me why do you use machine learning versus deep learning? Machine learning is just super quick, easy, truthfully, compared to the even this simple perceptron. It is a little bit more time compared to how quick it is to use. The default settings in the random forest actually work quite well as well. So you're not giving up a whole bunch here. You can see random forest on our test set did the rest. We notice some overfitting here. Kind of apparent in logistic and perceptron as well. And so things to work on. But you can see here, just by default, the perceptron did very similar to the logistic regression. That actually is because they're very similar. You don't really realize the logistic regression. What it's doing in sklearn is actually one-hot encoding all of the targets, so it's going to actually be 5 columns it's predicting, and the highest one of those is going to be your actual final classification for logistic, and the logistic regression is happening in each column, which is very similar to the 5 neurons up here that are predicting, or there are 5 neurons that are each predicting their own linear regression, and then the softmax is going to take the highest value of those. So kind of you don't really know this stuff, the inner workings of sklearn, because it's just kind of done for you. But to do the linear algebra, they need to convert to the one-hot encoded. Each column gets a class, or each class gets its own column, um, and so yeah. And so getting good practice, more in-depth understanding of the mathematics that happen in sklearn. And but anyway, so now we know how to do perceptron and this concept of the function model. We can just keep building it on. We just connect this layer to the next layer, and we multiply the output of the next layer to the next layer. And we'll see how to make it deep forward in later classes. And thank you very much for joining me today, and I will see you next time.